Let's make use of this question to understand the idea of limits. So let's read the question again. We are looking at the speed of an object which is under free fall at exactly 2 seconds. That is your instantaneous speed. So we have an object. It's been pulled by the gravity, so that's the only force acting on it. So at time t is equal to 0, the object is over here. Say at 2, it's over here. So we have it moving in this manner. So this is t is equal to 0 second, and this is u is equal to 0 meter per second. It's getting accelerated with the acceleration of 10 meter per second square, and we're looking at the final velocity for t is equal to 2 second. So one of the ways of going over doing this is v is equal to u plus at. So this is 0 plus a is 10 and t is 2. So that is 20 meter per second. It's a simple straightforward scenario, but we're not approaching this way. We are actually going to approach in a different way, and this is the way that this formula is derived. To be honest, what we're learning is we're learning a methodology which helps us actually derive this. So using this is not the ideal thing, because how it came into being is something that we need to understand, right? How can we derive this formula is what we have to understand, right? So actual basics is limits, and on that this is built. But yeah, I use this so that we know the actual answer, so that we can understand the entire picture better, nothing else. Now, if I want to find it some other way, the other way being this, I'm going to take up a table. I'm going to take up the time from 0 to 2 seconds. And I'm going to plot or find the distance in meters for this set of values from 0 to 2 seconds. Okay, so basically it's going to be something like this. So we are looking at 1, 2, 3, 4 blocks. The first block has to do with time and distance. Second block has to do with time and velocity. Third block has to do with the graph of this particular set of values. Fourth block has to do with the graph of this particular set of value. So how to understand this, what exactly you're looking at, is something that I'm going to talk now. Let me copy this first. So of course, instead of doing it manually, I've programmed to take up random seconds between a time interval of 0 to 1.99. Because at 2 we know where it's going to be using s is equal to 5 into t square, right? So that is the formula that we are using to calculate all of this. So it's over here. Okay, you're using this to figure out the distance. Now, this is a different set of distance that we have over here. Why is that, and what is that we are doing this, and why is that we did that? We'll understand in a second. So first thing is we are looking at velocity at 2 seconds, right? We're going to make use of the formula change in distance by change in time. That's nothing but velocity, is it not? So what is change in distance? Change in distance, we can do this. Distance at 2 seconds divided by distance at some I second, random second, divided by t is equal to 2 minus t is equal to I. So since we are talking about 2 seconds over here, so this value is fixed and this value is fixed, right? So basically actually we're calculating this velocity at 2 seconds is the distance that is traveled at 2 seconds. So t into 2 square minus si, this entire thing divided by 2 minus ti. So where is that we're getting this ti and si from? This are your ti and that's your si. So let me take up some random example, say 1.43. So I'm finding the velocity with the help of this particular value. Okay, at this time, this is the distance traveled, So basically we have to do 20 minus 10.2122 approximately. This entire thing divided by 2 minus 1.43. All we are doing is distance, change in distance by change in time. As simple as that. This value is nothing but, this particular calculation is nothing but this value. So this is the table which has taken different TIs and calculated the velocity at 2 for different scenarios. So here the velocity turns out to be 17.146, that is 15 meter per second. So what is the point of this? Well, you guys need to observe the following. Which value over here, which time gives a better answer, better velocity value to us. So question is, which TI gives the best V value? Yeah. What is that? Correct, 1.99. It is close to 20 than anything else. Right? This is the closest. This is closer to 20 than anything else. Now let's make this observation from the other end. That is by taking time interval which is from 2 to 4. This was 0 to 2, right? Let's make use of 2 to 4. So let me do this, and so similar to the previous thing, please make your observation. Which value of Ti gives you the best velocity? Is it Ti at 4 or Ti at 2.01? Ti at 4 is 30, and then 20, 27, 26, 26, so on and so forth. So what is that we can observe? Yes, this is a better value. Overall, what can you conclude? From both the ends, we're getting a better answer when we are, yes, closer to a time interval which is near to 2. Closer to better the answer. Agree? So as a whole, we can conclude the following. Smallest time interval starting at 2, we get better idea of the velocity at t is equal to 2. Closer the better. Closer the better. Okay, let me explain it in another terms with the help of a graph. Please understand that you guys can also be doing this. You can also do whatever you guys can see, because the code is available, the Python ID is available. Go to our required link, click on it, go to the required IDE, required code set, and then you can execute and have a look at all of this. Now, this first thing is, this is a distance versus time graph. This is your distance traveled by the object, which is under free fall. This line is the slope of these 2 points. Between these 2 points, a line connecting this. The slope of this is given over here. Sorry, I'll express it again. I have 2 different points which is on the distance versus time graph. The slope of this line will give you the velocity. Is it not? The slope of these 2 points will give you the velocity, that is the average velocity and all of that. Now I can vary this, I can make it go far away or get closer to 2 seconds. What you guys have to observe is, as when I go further away, will the slope get closer to 20 or away from 20? Is it getting away or closer to 20? Right? It is increasing. Now if I decrease the value, is it getting closer to 20? Is it better? Is this better than what we saw before? Is it getting better? 25, the slope is 25. I'm getting closer and closer to 2 seconds. So what is that you are able to observe over here? As when I get closer and closer, I get a better value of the velocity. Now I'll go the other way around. So you can see the closest is over here. Okay, not over there, over here. And we got a pretty decent value, 20.15. Now, if I happen to go away from it again to the other end, so what is happening? The value is getting away from 20. That is, the velocity is less approximate than what it was before. But now if I come back to that point, we can see that it is getting better and better. If I happen to zoom in, we can see that there are pretty decent scope, right? So I am able to get even closer. If I keep doing this, right, I'm getting closer and closer, and the value is getting more approximately. The approximation is better than before. We're getting a better approximation. We're getting closer to the actual value. So what is the conclusion? Closer the better, right? Denominator value, as in when it get closer, over here time, as in when it closer, this calculation value will get closer, and the overall result will be, yes, 20. Of course, I can't get even further. I mean, I can get closer to this. Okay, that's good, but not more than this. This limitation is because of my code. The way I have coded is this approximation. We have to change this value, val step, to get a better approximation. So end of it, what is the conclusion? The main thing is the conclusion. All of the other things are to get to this point, and the point is that closer the better, right? So limits helps us to do this. Limits pushes you to as close as possible to the actual value. That's the basic idea of limit. So we'll be understanding all of this a lot better with a lot more examples and lot more explanation on the limits, and the different things about limits will be understood in the next set of videos.